oder du hast eine Abhängigkeit.
Ja.
Entweder das eine oder das andere. Eins von beiden muss sein.
Wenn du aufteilen in eigene Lips, dann...
Entweder hast du die Abhängigkeit und du gehst sie ein, wenn es passt, und wenn nicht, dann duplizierst du halt und dann ist gut.
Ich finde das Duplizieren viel weniger schlimm, ehrlich gesagt.
Nein, ist auch nicht schlimm. Das ist absolut nicht schlimm.
Löschen, fertig, jetzt
Ist nicht schlimm.
sonst musst du auch noch...
Are you good?
Yes. Can you start the broadcast?
Is it good? Is it good?
Yes.
We've got 2 minutes left. Ist gut. Am Ende macht ihr dann, ne? Also wenn wir fertig sind, kommst du und sagst dann 2, 3 Takte, oder? Ja, ist okay. Und dann müssen wir switchen und dann kommt Adam. Cool. Got 1 minute left. Should we start? Should we start already?
We have 1 minute,
1 minute left?
but we are on screen.
Nah.
Once upon a time, there was
We
a
got
user
1
group.
minute left. Starting on time and trying to.
Yes, the Swiss way.
Stream is working?
I think so. Let me check.
Yes.
Still in.
Yes. 6 p.m. Just waiting for the go. Are you good? Perfect. I would say we can start. So, welcome everybody to the October's meetup. We are very, very happy that you're here. As you can see, we've got new equipment going on. So this is the first time we are using this. So bear with us if something does not work. As usual, we have a technician here, and he can set up and fix everything. So we are trying to get this going well. So thank you very much for being with us. Who are we? We are the .NET user group in Zurich. We are developers by ourselves. We're trying to deliver content from developers for developers. So we are very glad that you're here. We want to share knowledge and get you excited about technology. And if you want to get started in public speaking, this is the right place to do, you know. Get started in a nice little user group, right? The people in front of you are not that many. It's not that a big of a stage. So if you fail, it really nothing happens. The people have a beer. It's a very comfy situation for you, right? So if you want to get started in public speaking, feel free to do so. Just give us a message and maybe you will be the next presenter up here. We would be glad to see you.
Yeah, more things you can do is, if you don't do that already, you can follow us in Twitter. We have .NET Zurich, the account, and also in Meetup, but probably if you are here, is that you are following us in Meetup. And we have also the user group in LinkedIn. Who is not following us in LinkedIn? Out.
Know the faces, you know. We know.
But you're in Twitter, you are following us in Twitter? Same. That's good. And what Fabian said, we are open for people to speak. We usually lately are having this year short speeches which work really well. Previously different, but usually we have like 25, 30 minutes, and that's really working well. And so it's less scary if you would like to share something about what you do, or about your work, or some technology you know, so you're very welcome to do that.
Yes. So, first of all, one of the first things we'd like to do is thank Isolutions for providing the venue today. We want to thank you for providing beer and food today. So we have beer and pizza after the talks. We have a great venue here. I really, really like it. We also had workshops here. It's a really, really great place to learn, to speak, and to listen to the speakers. So I would love you to have a big round of applause for Isolutions providing all the good stuff today. Thank you very much. Thank you.
To concretely, Damien and Marc, thank you, both of you. All right, we would like to thank the sponsors like M&S, Bilbao, offering solutions, and of course, for Texture for his unlimited support over these years that we're having with you. Also, some old, but we still care about them, Impact Hub Zurich and the Stanford Group that were sponsoring regularly the venue. So we keep you in the heart. Maybe we will come back to these places. And then our beloved partners, the Azure User Group, .NET Central User Group, .NET Day Switzerland, and Swiss Angular. So thank you so much to the sponsors.
Okay, first talk of today, and actually the whole meetup was being started with Adam coming towards me and saying, hey, I've got a talk, and I would love to have a stage, and could you provide me some, and then I can get a talk going. And here we are, basically. We're very looking forward to Adam with 5 common mistakes with distributed systems, right? So that's the first talk of today.
Mm-hmm. And then we have another, which is, I put the other one.
That's okay.
So with Stephen, good friend, amazing speaker. He's super fun. He's going to talk about this diamond testing concept and explain how to get it done. So that's it for the speakers. I missed that one. So yeah, that's a good picture of holding the biggest fish, which is a competition in the .NET Day, right?
So last but not least, we want to do a little bit of advertisement because Isolutions, or in person of Damien, who is he? There he is. He's the biggest security guy in Switzerland. So every time I have a question about application security, about web security, I'm going towards Damien and he can help me out. And he is doing a workshop, application security workshop in Bern for .NET developers and architects. And we really, really recommend going there. It's a really, really important topic and nobody really has a clue what is going on there. He has. So if you have any questions, go to him, ask him the questions, or even better, attend to this workshop. His link, you're getting the slides over like LinkedIn or Twitter, wherever you follow us, and then you can register for it. I would really, really recommend going there.
If I may add, I think it's just announced, right? Like 1 day ago. So it may still have places, just saying. So that's it for our presentation.
Yeah, warm welcome to everybody as well from my side. We love to see that many people, that many
geographically through LAN, across the WAN, across the internet, you end up actually increasing things in orders of magnitude. And I want to try and illustrate that. So, it's really useful. So what we're going to do is we're going to take one CPU cycle, which takes about 0.3 nanoseconds on a monoprocessor, and we're going to scale it up to 1 second. Now, the reason I'm going to do this is because as humans, we're not very good at distinguishing between nanoseconds and microseconds and milliseconds. It's all just fast, right? You hear something that takes a few milliseconds, yeah, that's fast. But in order to understand the difference, the relative cost of these things, I'm going to scale these up so that one CPU cycle is 1 second, and then we're going to look at some other things that might happen. Level 1 cache access, like a nanosecond, so up to 3 seconds. Level 2 cache access, level 3 cache access, 12 nanoseconds. It's really fast, but on this scale, we're up to now 36 seconds relative to a CPU cycle. Then we want to access RAM, right? So this might be, I don't know, this might be like newing up an object or something. We're in the order of minutes, okay? 120 nanoseconds. Then we want to access a disk. A modern SSD is about 50 to 150 microseconds, right? Now we're in the order of days, right? So now you get an idea of the relative, you know, if I said to you a few nanoseconds, a few microseconds, you're going, yeah, that's really fast. That's all less than 1 millisecond. But the relative difference is 1 second, days, okay, to access an SSD. We don't very often use hard drives anymore, but now we're into months, right, up to even a year. Then when we actually start making a network call, this is within the same continent, right, 40 milliseconds, it's pretty damn fast. Years, right? On this scale, 4 years, where one CPU cycle equals 1 second. Let's have another look at this code. What's the relative cost of these two calls? Seconds, years, okay? Imagine what it's like to experience a second. Imagine what it's like to experience a year. Anyone use dependency injection? Right, dependency injection is great, right? You declare a dependency on iProcess data, you get this thing injected, you don't care at this point what it is, you just know it respects that interface and you make the call. But the thing is, what we're doing is we're hiding this line of code, right? And you roll it out to production, users say it's slow. And so, well, what do you mean it's slow? Where is it slow? Where's the culprit? We've done such a good job of hiding where our remote notifications are when we read our code, it's actually really difficult to find the culprit. So let's go back to our table. We want to go from one continent to another, San Francisco to London. We're talking doubling it up to 8 years. We want to go around the world, 20 years, right? We're in the region of decades now. This is when everything goes well, okay? This is the best case scenario. But sometimes a TCP packet doesn't arrive at its destination. Why? I don't know, network, right? Stuff happens on the network. But TCP is really cool because it can figure out it has to retransmit a packet, okay? So it'll do that for us. It takes about 1 to 3 seconds to do that. We're in the order of centuries now. An OS virtualization system reboot, again, centuries. Something like a SCSI command timeout, right? The disks that your servers are using. We're in the order of millennia now. Hardware virtualization system reboot, physical system reboot, you know, still has to happen sometimes. 12,000 years. Now, I'm driving this home because as developers, we're not great at realizing the relative impact of that call on our system. You know, anyone here running in the cloud? Anyone? That's actually more than half of you. That was a lot less when I asked that a few years ago. But the thing is, the cloud, what's the idea of the cloud, right? The cloud means you can just provision loads of cheap machines really fast, right? You need 1,000 machines, you just turn the tap or move the slider. Now you can provision machines at that scale, but you have to sacrifice some level of reliability, right? They will get rebooted and restarted now and then. If you were running in the cloud, you're actually at more risk of this bad stuff happening. So it's really important to realize that when this bad stuff happens, you're at that much more risk of paying orders of magnitude more cost as you're making those network calls. And this is backed by physics, right? I mean, this stuff down here, you can kind of like work on making it a bit faster, but getting stuff across the internet, the speed of light is a hard constant. We can't really beat the speed of light unless we get quantum computing. Then you can flip one bit in San Francisco and it flips at the same time in Sydney, and you can sort of throw this whole thing away. But I don't know if that's going to be a thing during my career. Most of this has held for the last 40 or 50 years. It will probably hold for another 40 or 50 years. So let's look back at our system. We don't have a lot of network calls going on here right now, but then we're only just getting started here. Anyone remember WCF? Right, yeah, remember that? So remember when everyone was saying like everything should be a service contract? So you can just sort of lift and shift everything out into a remote machine whenever you like, and you end up creating loads of little things with loads of network calls happening between them. Anyone heard of microservices? Look familiar? Okay, and sometimes, with enough calls and coupling and going on between these things, you might even end up with a sort of distributed monolith, right? So it's all running on different machines, but it's kind of like, it's still this kind of monolithic thing that's very coupled together. Now, let's have a look at what this does to our performance, okay? So if you think about the monolith, right, just that one box running on one machine, what tends to happen is as load increases, throughput tends to increase fairly linearly, right? But at some point, it starts to level off a bit. And this is to do with resource contention, which I'll get into in a minute. So it can sometimes get so bad that it actually kind of like falls off a cliff completely, right? And as load increases, your throughput kind of like drops to the floor. And this is a .NET user group, which is great because .NET's a great example, okay? So .NET has a thing called garbage collection. So when you try and allocate an object in .NET, var x equals new foo, .NET will say, okay, well, can I do a Gen 0 garbage collection here? Right, there are 3 generations, Gen 0, Gen 1, and Gen 2. There's also technically the large object heap, but you can kind of think of that as part of Gen 2 for this discussion. It will say, all right, you're trying to allocate an object, can I do a Gen 0 collection? And then it will clear up very short-lived variables, like variables which are declared in methods, the methods have exited, it can clear that memory up and deallocate it. If it can't, if it finds an object which is still rooted somewhere, like a class variable or something, it will promote it to Gen 1. Later on, a Gen 1 collection will take place. If that object still can't be cleared up, it will promote it to Gen 2. And at some point, .NET will decide it's time to do a Gen 2 garbage collection, right? One hasn't happened for a while. A Gen 2 garbage collection is a stop the world event, right? All your user threads are paused, and the only thread which is allowed to run is the one doing the garbage collection. Okay, it has changed slightly in recent years. I'll go into that in a second. But I don't know if you've ever seen this post by a guy called Marc. He used to work for Stack Overflow. And Stack Overflow were having real problems with this. And it turns out that when they analyzed these spikes here, where throughput was just completely, this is latency, so response time low equals good. These spikes in response time, these are Gen 2 garbage collections in .NET. And Stack Overflow the whole of Stack Overflow was effectively pausing for a Gen 2 garbage collection. So they did all kinds of crazy things to try and smooth these things out, like deallocating less objects and using other kind of tricks. And they managed to do that. And these days, .NET has things like the background collection and concurrent collection, that kind of thing. So again, it smooths out these peaks a little bit for you as well. But you can't get rid of the Gen 2 collection, right? Gen 2 collections have to be made. Okay, so the more resource contention you have, the more objects you're creating, the more often Gen 2 collections are going to take place, and they cause that slowdown and that drop off. If you're wondering how long a Gen 2 collection takes on our scale, it's in the millisecond to second range, so years or decades on our scale, right? So a Gen 2 garbage collection has a relative high effect on your performance when it happens. If we look at the distributed monolith, with all those network calls, at the beginning, it scales fairly linearly, you know, but the thing is, it doesn't scale quite as fast with the load because you've actually got network calls happening, right? So throughput scales slightly, like the rate of change is slightly less. But the thing is, those threads, because we're making network calls, I mean, not necessarily threads, you might be using async to make that efficient, but the objects are still in memory waiting for responses, right? Each HTTP response takes longer, objects live longer in memory, therefore, more Gen 2 collections, more slowdown, and the drop-off tends to happen earlier, right? So by distributing our system, we've made it worse, right? And that wasn't the intention. So the first rule of distributed systems is don't distribute your system, right? Unless you have an observable reason to do so, right? If you do have an observable reason to do so, like you cannot scale that one big machine anymore, then sure, start to distribute something. But the one common mistake that I've seen is distributing everything, right? You need to be very selective with what you distribute and you need to realize the costs. Let's go back to our distributed monolith. So I've created these before in my career. And when I've realized, it's like, oh my God, you know, what have I created here? This is really difficult. This isn't good. It's difficult to work on. I spend so much time battling with the system rather than delivering new functionality. Has anyone ever wanted to rewrite their system? Anyone? That's probably most of you. Yeah, we've all been there, right? You know, it's like, I bet I could rewrite this in 6 months, right? And this time I will make it wonderful. This time I'm going to do it right. I'm going to practice all those things that I've learned, and we're going to do it beautifully this time. But it's difficult to get the time to do that, right? But the thing is, it is a thing, because when you start working on a system, as time goes by, you tend to deliver quite a lot of functionality. So, you know, you actually sort of deliver functionality at a fairly good rate. I mean, it starts to taper off a little bit, right? Because, you know, you have to fix the occasional bug, or as it gets more complex, there are just a few more things to change. But if you're in this kind of scenario where you've got so many things going on, it's so hard to reason about your system, things tend to taper off, right? And it can get so bad sometimes, and I've been in this situation, it can actually kind of flatten out completely. You know, I've worked on systems before where 6 months have gone by and we've thought, well, when was the last time we've delivered any new functionality to the user? Right? It's months ago, right? We've just been battling with the system ever since. Just trying to keep it running and just trying to fix all those bugs that are coming out. So when it does start to flatten out, what you often do is say, okay, we need to stop, right? This is getting too difficult to work on. And you go to the business, if you give me 6 months, we will rewrite this and it will be so good that you won't even you won't even know what to ask for before we've delivered it. You know, it'll just be so quick. So you haven't hit this plateau yet, so the business still like you, right? So they might say, okay, fine, you know, you're doing a good job, so let's trust you. Okay, I'll give you 6 months, and you're ecstatic, right? It's like, oh my God, I've finally got my permission to rewrite. So you feature freeze the old system, right? You don't add any new features to the new system, and you start from 0 with a rewrite, and your aim is to get back to where the new system is, and then you can switch off the old system and just keep working on the new one, right? Great plan. Only it doesn't only take 6 months, right? It's never taken me that 6 months that I thought it would. Why? As developers, we're not that great at estimating, generally. And, you know, often it's not our fault. Sometimes you just discover things in the old system that you're replacing, and you've forgotten about those hacks that went into it 18 months ago. And it's like, oh my God, you know, how are we going to make the new system do this? And you tell the business that you're facing all these problems and all the rest of it, and they're kind of like, they're very accommodating, saying, okay, but, you know, you're making progress, all good. At some point, though, something like GDPR comes along, right? And it's like, no, we need to make something happen differently, otherwise we're going to get shut down, right? Or we're going to get fined millions of euros and we'll have to shut down anyway. So the business says stop, right? They freeze the rewrite. And they persuade you to try and coax a little bit more functionality out of the old system, right? And it needs to happen because we're going to be in serious trouble otherwise. You've then got a situation where you've got the old system, your lovely new rewrite, and you know what? This stuff is already doing more than this, because while you were writing it, they were coming to you with, you know, oh, while you're there, can you just make it do this? So there's pressure to actually get this live and get it running at the same time. So you might say, right, we're going to release the new system. The users can use the old system for doing part of their job. They can use the new system for doing the new parts of their job, and they'll get that new functionality they wanted as well, right? So I think it's a good compromise. But they have to be able to work together somehow. They have to be kept in sync. We need to keep them consistent. So what do? In the middle, you drop in an integration layer, right, where magic happens. And this thing here can take on a life of its own, right? I've spent months and years working inside integration layers before. And you know, they end up, in the end, they almost always really suck because the old system really sucks. So they kind of end up doing all kinds of weird spaghetti, and this thing really becomes a thing unto its own, right? And at some point you realize, you know what? The old system is now bleeding into the new one, right? This integration layer is having to do some crazy things which we never thought we'd have to do. This entire thing has become this kind of new distributed monolith, right? It's really, really hard to work with. And at some point, you have a great idea. You say, you know what? We should do a rewrite of all of this, right? And I'm not making this up. The companies I've worked with in the past, I've seen that happen. I can even remember the names of systems. I'm not going to say them because we're actually streaming live. I have to be careful what I say. But I can remember when the new wonderful world was the big hot thing. Then it became this big kind of convoluted mess with the old system, and then the new came along, which is going to be the new project. The cycle repeats, and it can even repeat again. So that's my second common mistake with the distributed system, is rewriting everything, right? Don't try and do big bang rewrites. Evolve your system. So let's assume that we have split up our system into an ordering service, an inventory service, a billing service, and a shipping service. This might be some kind of e-commerce site, for instance, like something like Amazon, you know, or Digitech Galaxis or something like that. When I think about distributed system design, one metaphor which I like to use is a person walking into a building, right? A person walks into a building, goes up to the ordering desk and says, here's my order, right? I want a new phone and some accessories and whatever. Here's my credit card. Please send this to my address. And what you can then do is the ordering service can do an HTTP call to inventory, which is the equivalent of that ordering desk picking up the phone to inventory and saying, we've got an order here, have we got it in stock? And I think about that's kind of how an HTTP call works, right? You make the HTTP call, you wait for the response. So you're on the phone, you're saying, have we got this in stock? Inventory get on the phone to the warehouse, and they say, oh, hi warehouse, which might be a third-party supplier. Have we got this in stock? They say, yes, we have. So they put the phone down, and they pick up the phone to then, inventory picks up the phone to billing and says, we've got this in stock and we need to get payment for it. So pick up the phone to billing. Billing might call a credit card provider, say, has this person got credit? Can we actually authorize this payment? They say yes. They pick up the phone to shipping, right? So there's a big chain of phone calls happening here, right? The shipping call the courier and say, hey courier, can you pick this thing up? They say, yeah, we'll be there tomorrow. So they put the phone down. They say to billing, everything's fine. They put the phone down. And I didn't mean to press that. Let's get back to where we were. Billing put the phone down to shipping. Billing tell inventory that everything's okay. Inventory put that phone down. They tell ordering is okay. And finally, ordering puts the phone down and tells the user, yes, your order's good to go. Right? It will be delivered tomorrow. right? Has anyone seen, there's a famous Stack Overflow question, which I can't find for the life of me. I don't know where it's gone. It might have been taken down, I don't know. But a guy says, when an HTTP call comes into our system, we're making 28,000 HTTP calls in our back end to our microservices. Seriously, it does exist. It may be in archive.org or something. It's out there somewhere, and it's amazing. And when I hear that, I think, well, I'm glad you're having problems. Your system's telling you that something's wrong. I mean, you could do this slightly differently. You could say, well, ordering picks up the phone to inventory and then talks to them and talks to shipping and then talks to billing. They could even do it in parallel, right? You could pick up 3 phones at the same time and speed things up a little bit. And that's all fine, but what happens when something goes wrong, right? What happens when we're trying to call the inventory service and they're just not picking up the phone, right? The server's not responding, it's giving you back HTTP 500s or something like that. Well, then you can say to the ordering service, sorry, can't get through to the warehouse. Ordering say to the user, sorry, computer says no, can't take your order, come back later. Who comes back later? No one comes back later, they just go somewhere else, right? There's loads of choice out there. So we need a better design for this. We need a better approach. So you read about queues, right? And you read that queues are backed by disk, which they are. Okay, so you think, okay, well, if we put something in a queue, we know we're not going to lose it. So we're going to say, well, when the order comes in, when the user walks in, we're going to put a message into the queue, right? And this might be the equivalent of taking the order details and putting them in your outbox. And you say to the user, cool, we've got it. We're going to sort your order out. You can go home. It will be there in the day, right? Exactly the same as being on a website and saying, immediately, 200 OK, right? Message in the queue. We've got this. Then this event might get subscribed to from billing, inventory, and shipping. They then go and make their calls to their providers. That comes back. They send a message back to the queue. Ordering gets these messages back that everything's OK. And at this point, what does ordering have to do? Doesn't actually have to do anything, right? We've already told the user 200 OK. It just knows that everything's worked. Sometimes things don't work, right? This call up here to inventory might fail. So at that point, we can say, all right, we send a message back to the queue to say something went wrong. We send that message goes up to ordering, and at that point, ordering knows that something's gone wrong, and we need to do something about this, right? We need to maybe, I don't know, email the user and say, sorry, something went wrong with your order. But do we have to do that, right? Do we just have to say, oh, sorry, something's gone wrong? Or should we perhaps retry? Right? We could do an immediate retry, just like in memory, in a loop. Just say, OK, couldn't talk to the server this time, let's try again. We might retry again. That might fail again. We might retry once more. That might fail again. So we're saying, OK, we've tried 3 times now. It's still not working. Maybe we should wait a while, right? Maybe the server's being rebooted. So what you might do at this point is put a message back into the queue for 5 minutes, and then say, when the message comes back, we retry again. But it still might fail. So it's like, okay, well, maybe 5 minutes wasn't enough. Maybe we need to wait about maybe 15 minutes, right? This is what's known as exponential backoff. You wait longer and longer and longer. So you put the message back into the queue for maybe 15 minutes. Eventually, when that 15 minutes is up, the message will get delivered again. You'll make another retry, and this time it works, right? So you're good to go. So then you send the message back to the queue. That then ends up going back to ordering, and ordering knows everything's OK. But the thing is, how long do you retry for? This might never work, right? You might try 3 times instantly. You might try 4 or 5 times with some delayed messages, and it just still isn't working. At some point, it's better just to give up rather than to keep retrying. And you might actually be making things worse by retrying. So then you put the message into an error queue, and some support person can come along, have a look. Maybe they call the warehouse and say, look, our system's trying to talk to your API. It's just not responding. We've tried 6 times. And the person says, oh, yes, sorry, the server's offline. They reboot it. the support person can put the message back into the queue and everything can work as it should. Now, how long should ordering wait for all that to happen, right? Because if that doesn't happen for, just go back one, if that doesn't happen for a day maybe, I mean this person might be on their lunch break or something when this message comes through. It might take hours or even a day or so to sort this out. At some point, it's safer to assume that something's gone horribly wrong over here because ordering, which interacts with the customer, doesn't know what's going on here. So if it hasn't heard back in a day or 2 days, it's better to assume that something's gone horribly wrong and to tell the customer, look, sorry, but something's gone wrong with your order. And you make up for it somehow. You send them a voucher or give them a discount on the next order or something like that. So the way you can do that is when you send this initial message from ordering to the queue, you can send another message with a timeout with a delay of, say, I don't know, 6 hours or something, and say, when I get this message back in 6 hours, if I still haven't heard from inventory, and shipping and billing, by the way, I'm going to assume that something's gone wrong. And at that point, I'm going to email the customer and say, sorry, something's gone wrong. Now, there's a lot of infrastructure to write here, okay? If you want to do this, immediate retrying and this delay retrying and this sending a message to yourself in 6 hours, there's a lot of infrastructure code to write there. Some queuing systems will do most of it for you. So for the delays specifically, Azure Service Bus is a good example. You can say to Azure Service Bus, give me this message back in 6 hours, and it will just do it for you. Other queues, not so much. RabbitMQ doesn't have any facility for this. So we have to do something else with RabbitMQ. Now, ultimately, what we want is we want ordering to put a message in the queue and to get it back 6 hours later, right? Sending a message to itself 6 hours later. But because Rabbit can't do this, we have to do something else. And what we can do is we can introduce another queue here. RabbitMQ has a feature called time to live. And that means that you can set this for a queue. So you can say this queue has a time to live of 6 hours. If there are no subscribers to this queue, and a message sits there for 6 hours, it expires. So you put your message in there, and you just leave it sitting there, right? 6 hours goes past, the message expires. You can then use an exchange in Rabbit to say, when a message expires from this queue, move it to this other destination queue, right? And that's the one you subscribe to, and that goes to ordering 6 hours later. So using that trick, you can actually simulate a delayed message with RabbitMQ using this time to live. It's not what it's designed for, actually, but it's just a nice thing that you can use to simulate it. So that's all good. So if you want to simulate a delay of 15 seconds, you create a queue with a 15-second time to live. If you want a 30-second delay, you create a queue with a 30-second time to live, and so forth with 60 seconds and 120 seconds. So now we can have delays of 15, 30, 60, or 120 seconds by creating these 4 queues in the middle. That's great. That works beautifully. But the problem is, this is the API. This is actually the End Service Bus API, right, for requesting a delayed message. Time span from seconds, you can write anything you like in there, right? Any kind of time span you want. If you want, you can be really evil, and you can write random.next, right? I don't know if there's a business use case for that. Maybe there is somewhere. You know, I might have to jitter something or something. And you can stick that in there. And what that means is that you can have arbitrary delays, right? The API allows arbitrary delays. And we could, in End Service Bus, create a queue for every unique delay that's given to us. But we don't want customers coming back and saying, why is End Service Bus creating 30,000 queues in my broker? Or you're using too many different delays, right? Use less. That's not a very good answer. So we need something different. Let's take a simple example, 42 seconds, right? Everyone likes the number 42. Now, you only write 42 as 4 and 2 in base 10, right? That's 42 in base 10, right? Base 10 is the system we invented for counting because of our fingers. But as computer programmers, we know there are other ways of writing numbers, right? You can write a number in base 2 or binary. And in binary, 42 in base 10 is 101,010. Knowing that, we can create queues with a 32-second time to live, a 16, an 8, a 4, a 2, and a 1. We can write our 42 in base 10 as 101,010 below those queues. This tells us that because this has a 1 underneath it, we're going to put it into this queue first. That one's got a 0 underneath, so we're going to skip that queue. And we're going to exchange it into the 8-second queue instead. That one's got a 1 underneath it, so it goes through that queue. The next one's got a 0, we skip that one, we go through the 2 queue, and we skip the 1 queue. So by putting this message through the 32, 8, and 2-second queues, we've simulated a delay of 42 seconds. Okay, so we haven't seen anyone else that's doing this. This is something we came up with, and it seems to work pretty well. Using these 6 queues, obviously we can only have a delay of up to, 63 seconds, right? But we do create more than 6 queues. We actually create 28 queues. That gives us a maximum possible delay of 2 to 28 seconds, which is that many seconds, which is about 8.5 years, which I think is probably enough for anyone. Why did we come up with 28 queues? Well, first of all, we thought 1 year is probably enough. You probably don't need to delay anything more than 1 year. Businesses don't really plan a year in advance. So it's all yearly budgeting and annual this and annual that. But 25, that would have been done with 25 queues. 25 queues, you could delay it for a year. 25 is an odd number, so obviously we went for 26. And then we thought, just to be really safe, we'll go one more to 27. 27's odd, so we don't like that, so we went to 28. So 28 it's a bit arbitrary. We were really tempted to go for 32, because obviously 32 is a number we like. But that would have given a maximum possible delay of 136 years, which, I mean, it's nice to think that someone might be using our product in 136 years, but it's maybe a little far-fetched. If anyone needs more than 8.5 years, we'll add a 29th queue, whatever, and maybe a 30th to make it even. I've only really sort of skimmed through that really quickly. If you want to look at that in more detail, you can follow this URL. This is another talk that I give that goes into delayed messaging and all that kind of thing in a lot more detail, and I actually show you how to do it in code and all that kind of stuff. I think we can share the slides after as well, right? So if you don't get the URL now, you can grab it later. Now, all of that stuff that I've described, all of this immediate retrying, delaying, delaying here, delayed retries, not to mention things like serialization, like getting things in and out of the queue, because they all work with byte arrays generally. Even Azure Service Bus, right? Azure Service Bus, don't be fooled by the name, it is just a queue, right? It's quite low level, it just gives you bytes, basically. So serialization, making sure that your messages are transactional with your database operations and that kind of thing. There's a lot of code to write here, and that kind of code is really fun to write. It's like you can create your own framework, right? You can create your own service bus. And this is what I've done in the past, and this is what I see people doing now quite a lot. But whatever you do, I would say to you, do not do that, right? There's plenty of products on the market. It's not just Send Service Bus. There's Mass Transit, there's Rebus, there's all kinds of things. But this is my third common mistake, is building a service bus, right? And it's very tempting because you're kind of like coming up with the requirements and solving them, right? You don't have annoying business users coming up with requirements. You're kind of designing this framework yourself, and it's a load of fun to write. You might even open source it at some point. But be aware that that is a very, very expensive exercise, building your own service bus. Okay, who here would say they work with a complex system? Relatively complex system? Yeah, that's about half of you. So a lot of the systems that I've worked with, I would designate as complex during my career. Does anyone's system architecture look like this? I hope not, but yeah, I see some, yeah, maybe a little bit, yeah, some reluctant hands going up. Again, a lot of the systems that I've worked with, that I've created during my career, have followed this kind of topology. It's often known as the big ball of mud. And you know, when you're in this big ball of mud, it kind of feels a bit like this, right? You're drowning in this thing. It's so difficult to reason about it, to make changes. But we have better ideas. So we split things up into services. That all looks quite nice right now. Just a couple of arrows going between the boxes, like nice low coupling. But the thing is, sooner or later, the business might, or some business user might burst into your workspace and say, well, I've got a fantastic new idea. I was out playing golf with my buddies at the weekend. We've got this great new idea. We think we can make a load of money with this. Can you do it? And you think, I think we can, but what we're going to need is some data in here from this box over here, or the other way around. We need to share some data between these two services. That should be fine, right? This is what these services are designed for, right? They're designed to have nice interfaces, right? As long as you respect the API and you use this nice documented HTTP API that we've got, that should just work. And it might be something really, really innocuous, like the price of a product, right? 100 Swiss francs, right? We're going to just share the fact that this product costs 100 Swiss francs. So you make the change, roll out into production, and it works, and the business are ecstatic. They're so happy, they're making a load of money from this new feature. You're the superstar because you've made it happen, and everyone's happy. It's all really good. A couple of weeks go by, and they burst into your office again, and they say, well, I've had this other fantastic idea. I was out snowboarding last weekend with this great new idea. Do you think you can make it happen? And you realize you need to do the same kind of thing again, right? You need to share a bit of data between these two services. Worked okay last time, right? Didn't really cause any problems. So let's do it. And you roll it out and everyone's happy. Then you realize you need to do it again and again. You see where I'm going with this now? You might end up at some point in a situation kind of like this, right? If you're not careful. And no one sets out to do this, right? I never set out to do this. But after, I don't know, 6 months, a year, 18 months, I suddenly looked around horrified at what I created, and it's like, oh my God, this is just a big ball of mud. I mean, this time it's a distributed big ball of mud, right? Because you're running it on 4 machines, right? So all these things are talking to each other over the network. And why has this happened, right? Well, when I said that these services are going to share data, right? What if we could avoid sharing data? What if we could avoid that completely? Look at a simple example. When business people talk about customers and products, it's very tempting to get straight up on the whiteboard and draw a box for customer and a box for product, right? And you talk to them about these things, and you ask them what are these things. You realize, well, there's a first name and a last name and a status. This is like gold status, silver status, bronze status, or something like that. Product has a name, a description, and the price, like really obvious things, right? And these are nice entities that we can create. The thing is, in order to do something meaningful, we're going to have to share some data here, right? In particular, in order to work out what to charge the customer, we need to get their status, and we need to get the price, and we need to do some kind of multiplication or something, right? If they're a gold customer, we give them 20% off. If they're silver, we give them 10% off. If they're bronze, we give them 5% off. So you're going to have to get data from these two services, either send the data from one service to another, or have some kind of orchestrator that's looking at both, and it has to do this kind of multiplication. But if we look at the detail inside these things, some other patterns may emerge. So if we look at the customer service first, and we say, well, the first name and the last name. Let me ask you a dumb question. If the last name is more than 20 characters long, does that change their status? And the business might look at you and say, that's ridiculous, right? Not only would we do something that dumb, no one in the industry would do something that dumb. Now, you've just struck gold, right? Because what have they told you? They've told you there is no relationship between customers' names and their status. So why are they in the same box? Let's put them in 2 different boxes, okay? And this is what you're trying to do at this stage of modeling. You're trying to look for piles of related things, right? These things are related, let's put them in this pile over here. These things are not related to those things, so let's put them in another pile, okay? Then we look at the product and we say, well, the name and the description kind of go together, right? Because if something's a luxury blah, the description tells you why it's luxury and why it's fantastic and why you have to buy it. So we put those together. And then we know that status has something to do with price, right? Because we know that we need the price and the status to work out what to charge the customer. So let's just put them in the same box as well, right? Let's just put them down here in the same related pile of stuff. And this is difficult for us because as humans, we are hardwired to think about concrete things, right? When someone talks about customers and products, those are the things we hold on to. Has anyone read Eric Evans' book, DDD? Yeah, a few of you, right? So a little bit. Well, I bet you read the first half. Yeah, that's exactly what I did, right? All about entities, value objects, aggregate roots, and all that kind of stuff. Well, it's interesting because at some point, Eric actually said that he wished he'd put that in the second half of the book. I know. Yeah, because if you probably did the same as me. You read about entities and aggregate roots, and you ran to work and started creating entities and aggregate roots. And kind of like, the second half of the book, oh, I'll read it sometime. Yeah, whatever. So he wished he put it in the second half. Later on, he said he wished he'd just put it in an appendix. And later on, he even said he wished he'd left it out altogether, right? So I'll go ahead and say it. Entities, bad. Okay? Behaviors and use cases, good. Right? These are nouns. Okay? And if you ever hear something like customer has a first name or product has a name, look out for that has a in the middle. If you hear that, it's a good sign that you're going down an entity or noun-based approach. Right? You're actually modeling nouns rather than behaviors. Obviously, we need to relate these things to each other somehow, right? So we need to know that a customer's first name and a customer status are related somehow, and that's what we do with the IDs, right? So we share IDs between services, but not data, and the same with the products. Now, I am sort of skimming over that very quickly. If you want to know more about that, and I go into this in a lot more detail in another talk that I give, this is a URL for that. It's a talk called Finding Your Service Boundaries, where I go into that in much, much more detail. So that is my fourth common mistake, is defining services as nouns, right? Or entities, if you like. You don't want a house and a road service, you know, you might end up in a mess. Let's look back at our system. So let's just concentrate on this top half for a second. User makes their request with a browser. We say 200 OK immediately. We put a message on the queue, and we take things from there. We then send a message to inventory. Inventory goes and calls the warehouse. Let's assume that they do get through to the warehouse, right? Everything's working OK. But the warehouse just say, sorry, no stock, right? What do you do now? Well, you're kind of a bit stuck because you've already told the user 200 OK. So you realize, well, we shouldn't do this if we don't know we have stock, right? What we need to do is let's hold off on that for a second. Let's let the answer come back from the warehouse. So the warehouse say, okay, yes, this time we have got stock. Then we send the message back to the bus. That goes back to ordering knows everything's okay. And at that point, we say 200 okay. Okay, so not immediately, right? It's much better to do it that way. And then you realize, well, the same kind of applies to the rest of the system. What if we can't build them? What if we can't call the courier? So it's kind of tempting to say, well, I mean, the thing is, what if you don't get an answer back immediately, but you have to retry? Right? That takes time. It takes even more time if it's being retried with delayed messages from the queue. And at some point, you might realize that we can't retry anymore, or there's just no point, so you put it in the error queue, and the support person had to sort it out. Again, they might be on their lunch break, right? Or they might not be able to get through to the warehouse. This might take some hours to sort out. What's the browser going to do while all that's happening? Right? You've clicked buy now on your browser. It's not going to sit there for hours waiting for a response, right? It's going to time out, okay? Please come back later. Only they won't come back later. So you think, well, it's tempting to go back to this model, right? Because then we can be sure that we have the stock. And then inventory can pass that to billing, and we can be sure that we can charge a credit card, and we can be sure that we can ship it. And the lovely thing is that if shipping says, sorry, can't ship it, billing can kind of react to that and deauthorize the credit card payment. And inventory can react to that and say, okay, we don't need that item after all. And it can flow all the way back to the user. But we've already seen that the business have complained that that's really slow. And we've already seen that contention it causes. So you're kind of stuck because you want to make things fast and reliable, but you don't want to take an order if product is out of stock. So I'll give you a hint. It's not a technical problem. We always try and solve these things technically. And it's always my gut reaction to try and sort this out technically, to make things consistent. It's actually a business problem, right? If you describe what's happening to your business here, they'll just say, don't check the inventory, right? Just tell the user 200 okay. Don't bother checking inventory. If we're out of stock, we'll just order some more, right? And if the worst happens, if the manufacturer's not producing that thing anymore, we'll just say, sorry, here's a voucher for something else, 10% discount. Doesn't happen very often, it might, and we'll just do that. And the reason they do that is because they're business people. And the first rule of business is take the money. Anyone here doing an MBA, any chance? No? I didn't think you would be, but a friend of mine once enrolled in an MBA, and after a few months he pulled out because he realized that all the MBA was really telling him was that the first rule of business is take the money, and the rest is just like admin. So they will always say, if someone's trying to give you money, take it, right? That's the first rule of business. So knowing that, we can then say, right, we can go back to this model, and you might be in a funny situation where you've said okay, you go to inventory, you've got nothing in stock, but the rule is that we have to take one away from the inventory, but it's zero. We can't have -1 of something. And again, the business people will say, no, fine, negative inventory is absolutely fine, right? We've been doing that for years. It's a well-known thing in this business. Negative inventory is a thing that we know how to deal with. We will reorder. So those of you put your hands up about the Eric Evans DDE book, ubiquitous language, right? Something new has entered your ubiquitous language, right? You've learned there is such a thing as negative inventory, which to you intuitively as a computer programmer doesn't make sense because we like to make things consistent and when we like to model things around the real world, and having -1 of something doesn't make sense. But in the business world, it makes perfect sense. And you can say, right, well, that reordering stuff, I can help you with that because I can send a message to myself to come back at the end of the day to look at how much negative inventory we've got, and I can reorder to restock ourselves. And then based on what we've sold the last few days, I can project out a bit more and reorder some more. So this is where you can actually add some really good value to your business. So that's my 5th common mistake with distributed systems, is striving for consistency. Right? It's almost always not a technical problem, it's almost always a business problem. And by speaking to your users, you will not only solve the problem, you'll find new opportunities to add value. Now, who here works with this is just a bit of bonus content here. Who actually works with some kind of e-commerce site where you take money from users, right? I know you do, yeah, and a few more of you, right? So you've probably spotted a flaw in this, right? Because I've said so far that we take the order, we then say 200 okay immediately, and then we send the credit card details to billing. I'm sure you know that that's not really how it happens in real life. I mean, it does happen with some things. So like you can order clothes from Zalando, right? And you don't have to pay for them, you just get them and then you pay for them later. So it does work in some circumstances. But more often than not, you don't want to be doing that, right? You want to make sure that the user will pay for these goods before you confirm the order and send them out. So one thing I've hidden from the diagram so far is the actual website, okay? The website is not a service. I'll describe why in a minute. A website is an infrastructure component, right? And the website can have first of all, this service down here, this consists of many components. So it might have components A, B, C, X, Y, and Z. Now, the yellow boxes here, apologies if you're colorblind, but this is the yellow box here, and the yellow box I've drawn around that there, they are physical deployment boundaries, okay? So here we've got components A, B, C, X, Y, and Z deployed somewhere on some machines. We can also deploy a component from billing into the website, right? We can deploy a credit card validator into the website from the billing service, right? These blue boxes, this box here and these boxes here, they're logical boundaries. A service is a logical boundary that is distinct from physical deployment boundaries. The credit card validator can talk to a credit card company or Stripe or whatever it is. It can validate the credit card. It can say, yep, it's fine, we've pre-authorized the transaction, you're good to go. Likewise, ordering may consist of some other components, and it might have those deployed in some place here. It can also deploy another component D into the website, and it's that puts the message on the queue. Then the message goes out to billing, and at that point we say 200 OK, right? As soon as we put that message in the queue, we've basically written down the order, knowing the customer can pay for it, and then we say 200 OK, right? This time after credit card validation. Then, as we've seen before, the message goes down to billing. Billing may have to communicate with the payment provider again. It may not. I don't know. Depends on the use case. This might happen. This might be a pre-authorization. That might be a confirmation or something. Or it might just do internal invoicing or something like that. Sends a message back to the queue. Message goes back to ordering. The messages come back from shipping and whatever else. And we're good to go. Now, if you're wondering, if you're not sure how this sort of deployment into other places works, and I know I'm not going into much detail about that, and it seems a bit weird. It is a bit weird. When I first came across this approach, I found it a bit strange. But if you want a sort of much more detailed explanation of that, this is a link to a talk by a friend of mine called Mauro Servienti. He talks about this in great detail. He actually shows you how to do this. He demonstrates why the website is just an infrastructure piece of thing, and it has components from services deployed into it. So that's my sixth bonus mistake with distributed systems, is conflating service boundaries, which are logical, with deployment boundaries, which are physical. And this is a really fundamental thing. If you can let go of conflating physical with logical, it allows you to do so many other things, like finding the right service boundaries, which is really important. And I do talk a lot about this in the other talk that I linked to as well, the service boundaries talk. So I think I'm pretty much out of time. Yeah, I'm pretty much on time. All right, good. I hope you enjoyed that. Please ask me questions about this stuff. I like talking about it. So thanks very much for listening. I can do a Q&A now if you want. Yeah, I didn't know if you wanted to get on with the next section or... Anyone got any questions right now? Yeah.
Yeah, so for the retries, for the message and putting them back, you can have two ways, kind of. You can also have some retries in memory, like polling and stuff. Do you advocate for having one way of doing things, or there are cases for?
Okay, so all right. Okay, right. So if I understand correctly, you're saying the immediate retries. Obviously, you've got things like Poly, which might do that for you, right? That's interesting. I had a question. I had this exact question on our discussion forum a couple of weeks ago, and yes, you could use Poly for that. But the only thing is that if you're using some kind of service bus that knows about immediate retries and delayed retries, you can kind of set up a strategy there to say, well, you're going to do 3 immediate retries, and we're going to do for delayed retries. Poly won't do the delayed retries for you. That's the thing. So Poly will do stuff in memory, and it will do stuff in the process that's running, but it won't put that message back into the queue for you, right? So you kind of have to, you'd have to say, don't do any immediate retries, let Poly handle that, but then hand off back to the service bus to do delayed retries. I'd rather have the one less moving part. I'd rather have the single thing that does the immediate retries in memory, and it's really just a loop. It's just a loop in memory that does it. So that, that's the sort of the simplest part of the retries. Obviously, that won't make distinction between HTTP status code responses, but you can plug in a custom behavior for that as well. So it kind of just depends a little bit on how you want to react differently to different status codes. Then it might be worth using something like Poly because it's kind of got a lot of that built in. Don't you say accepted status codes and unaccepted status codes, or status codes worth retrying or something. So it might be a nice way to do it, but I would rather have the service bus take care of all the levels of retries, I think, to have one less moving part.
Yeah. From the Python master, it's like there should be one way of doing things preferably.
Yeah.
Like every time I see people do both, I'm just like, should we offload this to the service bus because that can obviously handle it?
Yeah.
Or we can handle immediate retries, and we can handle the retries, or should we actually have a plan? Because now .NET actually integrates all the alone in the framework.
Yeah. And Service Bus will also do the, it's not worth trying anymore, put it in the error queue for you as well, which obviously Poly will have no information about. Anyone got any more questions at the moment before we hand over to the next speaker? No? Okay.
So, thank you very much, and yeah, I think he deserves it. We'll take now a small pause to set up, so 5-10 minutes, and we continue.
Yeah.
You muted it, so now they can hear you.
Okay, perfect.
Now,
Does it work? Awesome. I can start, I guess, huh? Perfect. Thank you for having me here. I am the intermediate before the pizza arrives, so stick with me for the next 30 minutes. I am a bit in the way here. I will talk about API testing, so from microservices down to a bit lower level, because we will also code today in the next half an hour, I guess. Yeah, I will use the WebApplicationFactory. I guess everyone knows it, or not. I hope not, because then I can show you a short introduction to me if my pointy thingy here does work. It does not. Now it's working. Back. Who am I? Short introduction. I'm Steven Giesel. I work for myself. I am a Microsoft MVP. I am mainly in the Blazor area. I contribute a lot there, but hey, today I'm doing also ASP.NET Core stuff, so well, let's get you hooked. I do have my own blog. You can find me on LinkedIn, and you cannot find me on Twitter or X, or how it's called in a week, I don't know. That's my unique selling point. You will not find me there. I don't grasp the concept of that whole thing. A small advertisement on my or our own. The genius Fabian, also here, and myself, we will do a free webinar in ASP.NET Core and Angular with NX in the front end. If you're up to that, if you want to join, here is a small QR code, or you can just go to the link, and at some point this will be announced. I guess end of the year, somewhere around that, plus minus. Exactly, yeah, and it's totally free, so just join in, hang in with us, ask your questions, whatever you want, and we will build the full stack application. Okay, I want to talk a bit about API testing, and obviously I will simplify things, I will generalize things, and yeah, I will just propose you one model of doing so, which might mean it's not the perfect model for you. You have to obviously adapt those things. If you go out and you have this spark in your head, you want to try it out, that's my goal for today. Nothing more, nothing less. Who of you doesn't know this? That's perfect. Who does really enjoy this? Okay, one. Oh, two. Yeah, so many. Okay.
Except UI.
Except UI. Yes, good point. So everyone knows the good old testing pyramid. Everyone knows that. You get somehow teach in universities on the job that's the approach you should do. Then you have these things like test-driven development, which are cool. You should stick to that, and then reality hits. What's the problem with that? Well, there are things like you have very much isolated components. You might have an overemphasis on those. Without a strategy, this can become really tricky. So I worked in systems. There were like 10,000 unit tests. Does anyone have such experience like me? Yeah. How was it? Great. Did you feel more confident? Really? Yeah, I felt the same, because it gives you some kind of a false sense of security. My biggest problem is when we talk about unit tests, oftentimes people understand different things. Is it isolation? Is it runtime? Let's say it is something isolated for the time being. And what I found the most annoying part about them is people just tend to have their unit tests stick exactly to the public API of any class. So what does that mean? You change your API and your test breaks. The sense of that test was it should validate whatever you do, you refactor, it's still valid. But if your test and your production code breaks, yeah, well, this whole bottom there is just gone. So my proposal is not getting rid of unit tests, absolutely not. They are good, they have their purpose. What I want to show you, where I think there's a lot of value, is if you transform this more to a, let's call it diamond. It's not really a diamond, but you get the analogy, where we put more emphasis on integration testing, especially API testing. So yes, there's also end-to-end tests and UI tests. Everyone loves them. So what is the benefit of such a testing diamond, or of an emphasis on integration testing? my main point, you are a client of your API. You're a user, you're a consumer of your own stuff. That's good, because with unit tests, not really. That's not what you are. You're just testing things in isolation. But here, you are really testing something which goes to a database, which might go to a queue, which might go to things. In general, you write less tests, but they have the same quality. Quality in the means of that when something fails, that business process is impacted. And yeah, that sounds a bit like behavior-driven design or behavior-driven development, but it's different. We are not seeing spec flow today for the sake of it. Obviously, there's still a space for UI and end-to-end tests. I don't know, UI tests. I'm not the keenest. Who likes UI tests? You like UI tests? 2 people. Why? So I worked in a project. I don't know why I have such extreme in my projects. Anyway, I worked in a project with over 2,000 Cypress tests. The test suite runs multiple hours until you get feedback, and obviously this is the extreme part of UI and end-to-end tests, but many of those tests, they could live here and could run in milliseconds to seconds. And yes, it's a living documentation. You write your tests in the way how a consumer or your client would interact with your backend. And it's perfect, because you can basically say, okay, my test does process an order, which includes billing, which includes all kinds of stuff you have. Okay, how can we achieve API testing? I spoiled it a bit. We are using the WebApplicationFactory, and without talking a bit too much, because I will show you in code what this is. Simplified, you have a .NET server which runs in memory. That thing runs completely in memory. You can spin it up super easily. It is very lightweight. I will show you the runtime in a minute. And you can basically set up every of your service. You can mock services. You can integrate configuration. And you don't have this problem like end-to-end test theft. If you think of how can you set up test data or other things with end-to-end, the default developers are doing is you have an explicit API endpoint, which is something with your database or set up your environment how you please so the test can run. You don't have this to do here because you're consuming your own stuff. The ability to use mock services I also will show in a second. What are the main advantages? Well, as I said, you are the consumer of your own API, which is for me the biggest gain and the biggest win, because you see exactly what your browser would do. Well, more technically, but it's still what the browser input would do at the end if you do an API call. We can also have the good thing of a startup. You can check what does your application do on startup. You can check that with a web service because it's a real server. Please don't use it in production. You can also check things like authentication, cookies, all this kinds of stuff which is somewhat related to your environment. You can check with the WebApplicationFactory because at the end it's just HTTP calls you're checking, or gPRC, whatever, gRPC, whatever you want to do. And the last thing where I do think it has a big advantage, you check serialization and deserialization. And if you just check controllers, you don't do this necessarily. This layer in between, you never check. And you check this with that. Okay, I talked enough. I'm someone who likes to code, so I want to code. I guess it's easier if we just open this and I just use one screen because that is way easier. Here's the cam for link, and we use it to mirror this. Do you see it? Perfect. Okay, let's go into my favorite IDE, Writer. Can you somewhat read this? It seems a bit pixelated. Can we crank up the resolution? Huh? No. But can you somewhat read it? This is readable for you. Perfect, perfect. Okay, I do have here some, your default web application. That's that, if you start a new ASP.NET web app, that is the default. It's the template. I didn't change much in it. And then on the other side, I have an XUnit test. So just that you see it here, it's just really XUnit. Let's make it a bit smaller. I hope you still can read this. So we have .NET 8 because it's, that's coming out in basically 1 month exactly. I'm using XUnit. I'm very much an XUnit fanboy. You can call me like that. And obviously, I use something like, I have fluent assertions also somewhere in here. Oh no, I reverted even. I will install fluent assertion in a second because I do not like this assert stuff from XUnit. It's just not sexy for me. And then I just referenced my project. So I didn't diverge much from the default template here. Okay, let's go to the program CS. And as you can see, I have here, let's make it a bit bigger because it's a bit pixelated. We have here the minimal API. Who never used minimal API? Okay, but you know what minimal API is? Okay, perfect, perfect. Then I don't have to explain much here. So what am I doing here? I have just my default route, and this just returns hey .NET user group. That's all it's doing. Okay, I want to write now that test. How would I write that test? Well, as you can see, I have here prepared my beautiful XUnit class with my very descriptive test name. I know there's, you can also use other syntax. I'm a keen fan of the underscore and having sentences describing your stuff, even though that sentence makes absolutely no sense. Okay, two things we need, or basically one thing we need. We need the WebApplicationFactory. And this differs now a bit from framework to framework. Again, I'm using XUnit, and to get dependencies or services in XUnit, what you normally do is you use the iClass fixture. And then you use whatever you want to have passed into your constructor. That's just the default way of XUnit, so there's nothing special. I want to have the WebApplicationFactory, and I want to have that of my own program. Now you can see there's a squiggly line coming up, which indicates I did something bad, or there's something not working as it should be. And if I hover over it, you will see, oh, they cannot access internal class program here. So this is a bit of a, I would say, a shame, more like if you're like a purist, not from a pragmatic point of view. So if you ever check the code, like this is this new template of .NET where you don't have public static class, public void main, that doesn't exist. If you don't have that, the compiler generates that for you. That's just what happens behind the scene. But what it also does, it's in creating an internal class. And yeah, we need somewhat that class because we need to spin up the server with it. So there are two ways. There's this famous internals visible to attribute. I'm not the biggest fan. Or that small cheat code you can do. You can basically say, hey, my class is, it's a partial class and it's of type program. And as you can see, that works. So you can see here that somehow my IDE is seeing that another part of a partial class is there, which is basically that part up here. And if we go back to my API test, as you can see here, no one is complaining anymore. One step further. Okay, now the next step we need to use this WebApplicationFactory somewhere. And I want to show you something with C#12, which I'm not sure if you want to like it or not gonna like it. But in C#12, there's something called primary constructors. And you can write your dependency injection a bit like Angular or TypeScript, where you put this as part of, it's not part of your constructor anymore, it's part of the class declaration. But what I can do is I can say here, I want to have my WebApplicationFactory in call that factory. And yes, that is absolutely valid code. What it does, it creates a factory private field in the background. I want to know who likes that new notation. Oh, there are a few. There are a few. Who's really like disliking it? Is there someone disliking that new notation with C#12? Yeah, you can. Yeah, the problem is if you're in a team, I don't know. It can happen, especially with tools like Writer and ReSharper. It will automatically ask you like, hey, use this because it's fancy and new. That's the only downside. You have to actively like shut down this code fix of Writer. But yeah, I mean for smaller things, if you have like one or two dependencies, I'm a keen fan of that. For more, it becomes very convoluted very quickly, especially if you also have like generic type constraints and then you have interfaces and maybe even a base class. But maybe then also your class might be a bit too big. Anyhow, how can we use that whole thing? With my factory, I can basically do everything. So the factory is the central component of the WebApplicationFactory. Makes sense. And here I can just create a client. I can do a lot of things. And as you can see here, it creates an HTTP client. So this is really what happens in the background is we just have an HTTP client. And he just makes HTTP requests to our service. And that's all the magic. I mean, obviously there's more magic, but the central point is exactly that. You are just the consumer of the API. So I can just create a client that is an HTTP client. And with that, I can just, here I have a lot of stuff. There's post as JSON. I can say, okay, get me something async or get me a string async. That's the case I want to have now. And I want to have a route that is just my index. And that's all. That thing is awaitable. So let's use tasks like one should. And I have a response which comes back. And if we check the response, we can say, okay, it has a status code. Oh, this one is directly the string. And now I didn't install fluent assertion. Assert equal? Guess so, huh? And here is a dot. I know, I steal it from here because I'm lazy. And here I want to have this one, and I want to get my string. So this will, for example, fail if the URI isn't there, isn't available. So if I just run that code, you can see here the small thingy. You can see it was green. That was very quick. Maybe I can also crank that up. Can I? No, I cannot. I hope you can see it, but it's green. Trust me. Okay, that's cool, but you cannot see it here, but it took 177 milliseconds. Quicker than any Cypress test, but slower than a unit test. The thing is, I will just copy paste that whole test. It doesn't do anything different, but I just copy the whole test. And now I run both tests with XUnit. And then you can see the first test it's really difficult to see on the right side. And anyway, my face is almost in the way. Here you can see there's, 122 milliseconds. And the second test is 0 milliseconds. So obviously, at some point, the server has to be spun up. And it happens, the first test is running. And after that, it's pretty quick. So if you have a lot of tests, it's not like every test will take 122 milliseconds. The first one is the slowest one because, stuff has to happen. But yeah.
Is that for the whole assembly or just for class?
That's the problem, it's just for the class. Good point, exactly. There will be a new one spinning up.
So just make one class?
Exactly. Basically, you create one test class where every test lives in. Make it partial, that's why we have this keyword. And you just, that was a joke. I'm not sure. Not that you quote me on that one in the future. Okay. I want to show you something now. We want to extend that service a bit. Let's go back to my program, and as you can see, there's still a map get. We have this URI, but it doesn't do anything. It's just a static resource. It's pretty boring. So what we can do is we create something like a DTO, like a request or response DTO. For the sake of it, let's create a request DTO. I'm keen fans of records. Let's call that request DTO, where I want to have a name. And this is just minimal API. You can just say I want to have a request DTO, DTO. Let's put this here on this line to make it a bit visible for you. And instead of hey.NET group, what I'm returning here is just from the DTO, the name. Obviously, my test would fail and wouldn't even run. Why wouldn't it run? It's a get. Get doesn't accept body parameters. So let's do a post. Now it's valid. And then here, obviously, we have to also use post. Not get, post as JSON async. And here you can see it wants to also have a value. Obviously, because it could say nothing, but I want to test that when I enter, for example, Stephen, there should be, hey, Stephen, as my return value. So let's take that request DTO we created a second ago. We have it. And let's call that Stephen. Let's maybe put it on a new line so everything is nice and visible. And then we have our response. And our response, you can see here, is now HTTP response message. So instead of getting directly the response, what we can do is like the text from the response is the content read as string async, and we are awaiting that. Easy peasy. I could also now check for 200 status code, but I don't want to do that. And obviously, it's not hey.NET user group. It's just hey Stephen. And did I do some extra stuff? No, I did not. Okay, let's run that. Obviously it's green because that's pretty straightforward. But what's the problem with that code? Does someone see a problem here?
You're referencing the same DPO. If that API changes,
Perfect, exactly. Perfect, exactly. So imagine, again, the central point is you are a client of your API. Imagine I create my backend application, Fabian's creating a front-end application, and then good old Steven decides, I don't want to call that name anymore. I call that, I don't know, full name. And obviously, my test would still work. That still works without any problem, obviously, because I'm referencing the same object, so it gets serialized in the same way. But if Fabian gets my code, he will be very mad at me because his stuff isn't working anymore because he's still setting name to me, not full name. Obviously, I could use Swagger and Zot, but I'm lazy. I don't do this. So yeah, the simple fix to that is don't use your production DTOs. That's just very simple. And C# helps you a lot with that because the simplest thing you can do is use anonymous objects. That's what they're made for. That's super simple. And you can just say here, full name. You can even misspell it. And let's call that Steven. If I run that test now, obviously this will work. But back again here, let's call that just name as it was before. Let's call it name. And let's call that test. And then we can see, ooh, that's not working. Somehow my entity was not really parsed. And the reason was, obviously, the structure doesn't fit. So I would very, very urge you for weak rests and response DTOs, never recycle your production stuff. It makes your life way harder because you have green tests even though a client would fail. If you use anonymous types, you get immediate feedback. Latest your CI/CD should tell you that was not a great change. Revert that, fix it, somehow do something with it. Okay.
Just a question. Why does your first test green again?
Sorry, I never executed it again. Sorry, yes. So if I call that yes method.
Can you repeat the question?
Yeah, sorry. The question was my first test, why was it green, even though I changed the HTTP verb, for example. But the sole reason was I never executed the test once again. Fair point, I maybe should just delete this. But I repeatedly called that test, and as you can see here, probably if I move it a bit to the left, you can see that I got a 4 or 5 method not allowed. Obviously, I tried to make a GET request against the post endpoint. Perfect. I changed something, and I got immediate feedback with my tests. OK. The next thing I want to show you, which is very awesome, because this is .NET, and you are under full control of your server, is you can just hook in to your whole DI container. Let's write a very stupid service. Greeter service or something like that. It might also have an interface in a second. And the only thing it does is it greets. You can put in a name. And what it does at the end is it just returns, what we had before. We just use this. Oh, come on, my MacBook. And then say, hey. And whatever you passed in, and maybe an exclamation mark, something. That's all. Let's create a small interface on top. Greeter service, which has the same, greet has a name. And that thing is implementing that. OK. Here are my services. I use Swagger even, but as you can see, not very successfully. So let's register this beautiful new service. Greeter service is a greeter service. OK. That done, I can use it basically in my minimal API in the way that I say I want to have my greeter service. And instead of doing this by hand, because I'm following obviously solid principles, I have a service for that, doing exactly that. Let's take that from the DTO. And if I would run that, well, it would fail, obviously, because I added this exclamation mark. But the rest is almost the same. And I should call it name and not full name. Thank you. So now the structure is fitting. And if I do now the exclamation mark, this one is working once again. Okay, this is nothing fancy. I didn't show you any trick because this is how you write production logic. The trick I can do here is I can hook into my whole startup process. So instead of saying just factory create my client, I can say with web host builder. And that thing might sound familiar because prior to .NET 7, that thing was used extensively in the startup class. And here you have access to literally everything. So here I have my configure services, which sounds like I can do something with my beautiful DI container, which I also will do. So I can here say C and add a new service. I can use this iGreeter service, and I will create a fake greeter service. That doesn't exist now, so let's create it. It doesn't do much special. Public class, fake greeter service. iGreeter service, and as you can see, I should implement that, and I can return just hello, without any name. Well, maybe I can put in the name. It doesn't matter. Let's put in the name. Why not? And now it's registered, and here's the test. It's registered. Here it's still sending the DTO, and if I run that test, as you can see, it's not passing anymore. And the sole reason why it's not passing anymore is, well, it's using my fake greeter service, and that's a good thing. Obviously, you don't want to exchange like something simple like a greeter service, but imagine you have a dependency to some Azure service or to some queue it's not live in your CI/CD. You can just fake them out to something which gives immediate feedback or which is more reliable. And because oftentimes you don't want to test the queue per se. Obviously, you also want to have queue tests, but you want to test that, for example, something went to the queue, another system does something or service, and then something comes back. And you want to basically have it as stable as possible, and your queue might or might not be up and running. And that's why you would fake out services inside tests, like you would in unit tests, because you also don't want to have these dependencies there. So to make that test pass, I could just say hello, Stephen, instead of hi, Stephen, whatever that means. And then you should also remove this one, because as you can see here, I never ever added that. But that is a very good thing for you to make your test stable. And one thing, or one more word of advice, is especially with .NET 8, with the new time provider. Anyone knows, or who didn't heard of time provider, the new time provider? Basically, that's a cool concept. We could make a whole talk just about that, because it's really cool. So you probably use something like an iTimer with a non-change event where you can say, hey, I have a due period, or you use something like task delay if you want to have like something like poly, where you want to increase like timeouts, you use something like task delay. Imagine you want to test poly, or your own implementation of poly. Obviously, what you don't want to do is you don't want to idle your test for like 5 minutes until your 3 retries are hit. And the new time provider is basically an abstract class which allows you to mock out such behavior. As even if you write task delay 1000, you can just in an instant just flip it and it's done. It's a completed task in an instant. So oftentimes when you have stuff like that, or concurrency and whatnot, with task delay, with timers, or datetime now is a very good example for that. The new iTime provider, sorry, not iTime provider, it's just time provider, it's an abstract class, not an interface. You can mock out this behavior completely, entirely. And I think that's a really great achievement. Hopefully third-party libraries will adopt that, because you're still in a weird spot if your third-party library is still using task delay. Then yeah, well, your code is nice, but the other code isn't. Anyway, back on track. Yeah, time provider is really great. I cannot stress this enough. And the cool thing is, I know .NET 8 it comes out in a month, and I cannot use .NET 8, but they backported that for .NET Standard 2.0. So even with your cool, fancy .NET Framework 4.5, you can use it. Obviously, as a NuGet package, it cannot be part of something which is already shipped, but you can install it as an external dependency and make your life easier. Okay, back on track. The last thing I want to show you in this small demo is if we go back here, oftentimes you have configuration set up. URLs, behaviors, whatnot. Obviously the iOptions pattern. I'm now a lazy man, and I just use the configuration manager. because why not? So there's iConfiguration, which allows you to grab information which resides in your app settings files. I have greeting, probably something like ending, and today I want to have the exclamation mark. That's something I want to have. Yeah, that sounds reasonable. And here I want to use this one. I know what's like that. And we want to add here from the configuration the ending. So this term, it would just do, the exclamation mark at the end. Nothing really big. Again, I would just stress out, use iOptions pattern, don't use the configuration manager on your own. That's just not the way to go. Back to our test, if I would run that, this would now fail for the reason that I added this sign. Obviously I added that because, that was in configuration, I configured it. And here, next to configure services, what you also can do is, sorry, that's inside here, you see, that's a big difference, is you can say, for example, use environment. So right now I'm having the development and my production. Via default, your development stuff will be taken into account. I can make this very much clear here. You see, when I rehearsed my own stuff, I used foo and not bar, and then I changed now. Anyway, now I want to have this exclamation mark instead. In the development and in the production code, I still have this one. Okay, let's delete this for the time being, because now my test will break. As you can see, it uses the question mark because it's development environment. But I want to simulate my production environment. So to do so, I can just say, too many exclamation marks here, use, that was here, use environment, and I could say production. And then it uses my production code. I can also say, like, use setting and override the stuff, but yeah, I don't do this now. I just say use production, which translates to this one. Let's go back to the test, and let's call that class, and as you can see, it's green now. So the whole idea, if I wrap this up before we can eat pizza and before it gets cold, is you can be really your own client of your API. You can mock out all the behavior, you can set up everything, and it works really blazingly fast. And in my opinion, I work with that a bit. You write less tests because your tests normally are telling you, okay, I just want to, even for CRUD applications, like a to-do app, you're like, okay, I want to save this down, I want to get all to-dos afterwards. It's just one test, and it tests your whole stack. And the best thing is for people who like TDD, you just write the test up front, because you don't need anything. You don't need any infrastructure in your production code. You just write the test. And afterwards, you can just implement everything. You don't have to wait every time, I have a new interface. Now I have to write that test. And then I have a second interface which has a dependency. Now I have to write that unit test. No. You just write everything up front, or later. It's up to you, whatever you prefer. And then you just implement that. And once you feel confident, you can just press that button and just run your test. And if the test is green, everything works. And you automatically, your service layer is tested, your repositories is tested. Depending on how you set it up, even your database is tested. And I do feel that is a very, very big advantage, which can accelerate development by a lot. Because I worked a lot with unit tests, which were kind of bound to the structure. And if you touch something, it just went down. You had like so many broken files, and then you fix those files, and the confidence of those unit tests is just gone. So if you go out today and you want to try that, then I'm very happy. You make me very happy. Thank you very much. If you have questions, just approach me.
Any question?
You mentioned the media a couple of times. What's your recommendation on stuff like databases?
Normally, in those applications I worked, I try to use something like SQLite. Either you can use it in memory or just a file. It doesn't matter. It really depends. Obviously, if you store procedures, it doesn't work. You need something like an SQL Server. I also, for example, the entity framework team, what they're doing, they have basically a simulator running. Like they have the default Cosmos DB emulator running for their tests, and they have many tests, and they don't take ages. So don't shy away from using your real stuff. With SQL Server, it depends a bit how easy this is, how easy you can set this up. Stuff like GitHub Actions and stuff, it's easier nowadays, it's easier. But my recommendation is try to use the real deal. And as a fallback, then something like SQLite.
For this, I've been using test containers. So for this question, I've been using test containers quite a bit. And the only check the situation that there's a smoother package that lets you spin up containers, for example, for the party. And so I can just check the use with the
Yeah.
And I have another question, and the question, in your experience, how has the feedback been when tests are failing? So is the feedback full enough to point you to the right?
Good question. And that depends also a bit on how you build those tests up. How much do they test? If you do the business case, you know that business case is broken. And the problem, you could argue, is you don't know what exact part of that stack is producing the error. Obviously, if there's an exception, that's the easy one because it bubbles up and you can just, you see it. That's straightforward. The cool thing is, which helps me here a lot, this is debuggable. So I can just run. Let's go into my program and set a breakpoint in here because, again, that's just in-memory stuff. Let's put a breakpoint here in this hey name. Great idea, I mocked it out. So probably I should put it somewhere here where my real code is hit. And you can basically debug your code if you want to. So that is, for me, something, as you can see, I'm just hitting, I hope you see it here, I'm hitting really the breakpoints. That is something which I feel makes it way easier to test your stuff. For example, if you get a 10, even though you expected a 20, then you, unfortunately, yes, you have to go down a bit. Obviously, if you have bugs, you can still write unit tests afterwards. If you feel like there's an area which needs a bit deeper coverage, then unit tests are still fine. I'm not talking against unit tests. I'm just talking about reducing the amounts of unit tests and shifting a bit the mental model, how you would write tests to accelerate yourself. Does it answer your question? Perfect.
We have time for only one more question. Sorry.
He waited long enough. I would.
Okay. And you can go to him after. Whoever is listening online.
How we eat pizza.
I'm just wondering, in your experience, if we don't end up writing more tests eventually, because the higher you go in the pyramid, the more you have to prepare your data. So eventually, you're hitting all the complexity of that class, and you're hitting all the complexity of another class, and then in order to prepare the data for the test, you suddenly have, I don't know, hundreds of combinations with your permutation.
That's a fair point, and yes, it could happen. The only thing which I can tell you, or what I do, which helps me a lot, because you have access to everything, you can make things like that way easier. So if you really know that there's a service which is very complex, you can just fake it out. And for that complex service, you can still write unit tests. Or maybe one test where you can just go through because it does maybe serialization, deserialization, and you want to obviously also cover that to some extent. That is what I do normally. So if there's tricky stuff, which is maybe either too complex or unreliable, you just fake it out. And then you can just try to test that either with a normal integration test, so not an API test, but an integration test in the classical sense, or unit tests, and then just set up everything on your own. So then you just need an initial seed data. For CRUD operations is anyway straightforward. You just create some entities. That would be my recommendation. Cool. Thank you very much, and enjoy your meal.